Hello everyone, my name is Martin Ramirez. I am a transportation engineer at Jacobs, doing a lot of design and modeling work. I attended Iowa State and got my start over in Minnesota, but I joined Jacobs, the Milwaukee office, in 2019. However, it was a combination of projects in Nevada that led me to the use of Subassembly Composer, which is today's topic. The first project that introduced me to the need for Subassembly Composer was one in which I was using inroads, and I got to see how modeling was done there. I found it very interesting how you create what Civil 3D calls subassemblies over there. It was done visually in a very graphical way that was technically coding, but it just never felt like you were coding anything. The next project that led me to having to use Subassembly Composer was one in which there were a lot of walls on the project and a lot of the design elements were changing. So I needed a more dynamic solution. And that's when I turned to Subassembly Composer because in my head, I knew how a subassembly should work, but I could not find the right one to use for my situations. That's when I decided to create my own, and I hope to teach you how to do the same. I don't intend for these to be used for production or anything like that. These are just my way of deriving the design information that I needed in a more intuitive and dynamic way. Okay, so for this introduction to Subassembly Composer, I'll be using the same scenario that I was faced with in Nevada. And once again, that was that we had a lot of walls and they were impacted by changes to alignments, profiles, things like that. And these changes were happening almost daily. So we're trying to get a visual way to see that walls change and update dynamically. We'll use this diagram just to get a rough outline of what we're trying to do in Subassembly Composer. And I broke it down to 7 steps. And so the first step will be defining the wall bottom at the back. And so that is this point right here. And for right now, that is the only point that we're able to determine if we know, for example, a wall thickness. Step number 2 will be defining the grading start location. This might represent an adjacent roadway that grades back towards our wall. The third step will be determining the minimum and maximum grades. In our situation, we were given a limit of 2 to 1, and so that's what I have here. 2 to 1 back, and then 2 to 1 going up, which this is the ideal point, but anything between this would technically be feasible. And the reason for having a top limit is that the fourth step will be that we're going to introduce another variable, and that is that even though we were in the desert, or what looks like the desert, there was a water table and we could not cut too deep. We could only go 12 feet down. And so we're going to add that limit. And the fifth step is making the wall variable. That is its height, because in some situations, like what's shown right here, even though this is the minimum wall height for the grade, it's not the minimum because we cannot cut below this limit. The sixth step will be when to build the wall. We're going to add it into the subassembly so it's a little bit more intelligent. There are situations where the wall would be below 0 height, and so we don't want it to build anything, because now the 7th step will be actually building the wall, and we only want it to build where we need it so that we can easily identify the wall length and the wall heights. Okay, so I've been going back and forth and re-recording this presentation, trying to see what the best way to introduce Subassembly Composer is. And I think what I'm going to try to do is give you an explanation of what you're seeing on screen, and then go a little bit more in depth with the things as we need them. So what you see right now is what you see if you first open the program. Off to the left, you have the toolbox, which has all the points, the auxiliary points, some more intelligent things like variables, sequences, decisions, and these are everything that we need to create our subassemblies. Once we need them, we'll be placing them here in the middle. That's where everything will be showing up. When we're placing them, they also have information within them that we can define down here on the properties. This over here is showing us what we have placed. And so it will go from this screen to this part of the screen, and you'll be able to see where it is. And if you update a property over here that affects where it's placed, it will be updating here. And then at the bottom right corner, we have where we input our information. Things that might be here are like widths, elevations, things like that. And there is also a section for targets. This might be a surface target, an offset target, all things that we'll be using. And so that is how everything is laid out. For the next part, we'll actually be using all of this, and it will give you a little bit more information about how to actually do the things. Okay, so from our first step, we determined that the first thing we needed to get was the wall bottom at the back of the wall. And for that, we'll be using our first input, and that is a wall thickness, which is usually something we already know. And so we come over to this part of the screen, we create a parameter. We're going to name it something that makes sense, wall thickness. For its type, there are a couple of options that you have. In our situation, it's a double, which is a number that has a decimal. And for that, we're going to give it a default value, something that we can see. I'll use 3 feet for now, and I'll show you how all of that works. So we have a wall thickness that we can assign to an auxiliary point. Our first auxiliary point will represent, from our diagram, this point right here. And so we need to give it a delta x, which is our wall thickness. Wall thickness. You can see it moved over 3 feet. This is all dynamic. If I type in 5, it'll go over a little bit more, but we'll leave it at 3 for now. And I guess a quick explanation is that if you use positive numbers, it goes to the right or up, negative is left or down. In our situation, all we need is a delta x because we do not have a wall height yet. And for right now, this should take care of step number 1. Our next step will be to determine the grading location. If we go back to the diagram, we got this point, next up was this point, and this was an adjacent roadway that had a location that we need to start from. And so in order for us to be able to tell it that, we'll be using targets. This is not an input because this could be variable. This roadway is independent of where our wall is. And so we don't need an input, we need targets. We'll be creating 2 targets because everything is done individually. The X and the Y are not linked together. So something that makes sense for target names are grading X and grading Y. For a type, there are 3 options. Grading X is an offset, and grading Y is an elevation. For the preview values, we'll just type in something that lets us see it relative to the wall and that it's easy to follow. I'll use 10 and 10. So now you can see that it's going to put a point along this plane and along this plane. We want it at the intersection, and that is where the grading will start. So we'll add another auxiliary point, for it to be able to read the targets, we're going to have to change its type from this to this one. This is the one that will bring up a couple more options. That includes overriding the delta x and the elevation. So notice how this is also intelligent and knows that we're trying to target an offset. So it's not showing us every target, just the ones that make sense. So grading x, and right here, grading y. If we scroll down a little bit, it's automatically adding a link, and it's connecting it to this point, which was the wall bottom. That link does not make sense in our situation, so we'll be turning that off. And now we have the first point set, the second point set, and we're ready for the next step. Our next step was to, after we determined the grading start location, we had to determine the maximum and minimum range of grades that were feasible due to the site situation and the geotech. So that is H1 for the minimum, H2 for the maximum, everything in between works, and we'll be adding these lines just so that we can visualize everything a little bit easier. In order to do that, we'll be needing another input, and that is the maximum grade. So for the name, I'll use max grade. For the type, I'll be using slope. The default value in Nevada, we were given 2:1. And so we're going to be placing 2 more auxiliary points using a combination of max grade and wall thickness to determine their location. The first one will be for the minimum grading or the minimum wall height. So we'll add that auxiliary point. For the type, that point will be placed at a slope from AP2, and that slope will go for a certain distance. And so we'll change the type to slope and delta x. From AP2, the slope will be max grade. Delta x will be a little bit more complicated than just using one of these things by itself. It will be a combination of things that require some math. And so what that math is that from AP2, once again, that was a positive number. We can get AP2's location in a negative number, but that would bring us all the way to the origin, which is not the back of the wall. And so what we need to do is subtract that distance. In order to do that, what we can do is say negative AP2.x and minus the wall thickness minus wall thickness. Okay, so it was not minus wall thickness, it was plus, because that's already a negative value. So we need to do plus. And it was negative max grade. So that will give us the first point. The second point is the same thing. Something that we do need to do is that we need to tell it that it's from AP2. Again, slope delta x, and that is max grade for a distance of negative AP2.x plus wall thickness. And so now we have, from our diagram, we have the range of values that are valid, and that should take care of step number 3. So for step number 3, what we were going to do is we were going to introduce another constraint, and that is that we had an existing ground and a max depth that we could use. And so for that, we'll need another target for the surface and another input for that depth. We'll switch over to the target tab. We'll create a parameter, name it existing ground or EG. The type is surface and the preview value we'll use 9. Another thing is that this is linked to what's going on over here. If I change this number to, let's say 10, it'll move up, or I could also drag it over here. This will be very useful later on when we're testing our subassembly. So we have the existing ground. We'll go ahead and add an auxiliary point for it. For its type, we want an offset at a surface. So that will be delta x on surface. The surface is that target, existing ground. And delta x, I will use a number of -5. The reason for that is that, let me go ahead and remove the link, is that I don't want that point to be overlapping over here for ease of reading it. That's the only reason that we're shifting it over a couple of feet. The next thing we're going to do is we're going to add that input of the thickness. I already had it on here, max depth, double 12 feet. So we'll go ahead and add that auxiliary point. Once again, delta x on surface, or sorry, not delta x on surface, it was delta x and delta y, with the delta y being that depth. And that is from that previous point. So negative max depth. We're going to remove that link because it doesn't represent anything. And I'll drag this so you can see how everything is updating. As the existing ground goes up, the depth also changes with it. And I can change it however I want, and it will update automatically. And everything is looking how it should. The next step will be finally defining the wall height and making a variable. Making a variable meaning that it will either be this point or this point, which is the cut limit or the minimum grade. In order to do that, we'll need to define a variable, and that variable will be the wall height. So for its name, we'll use wall height. And for its default, we'll be using what we ideally would want, which is the minimum grade. So that is AP3.y. For the type, it will be a double. At this point, what we have is that the height is AP3.y. We now have to tell it that there are situations where it'll be AP6. That situation will be if AP6 is higher than AP3. In order to do that, we'll need to add a decision. Well, the decision is, or the condition is AP6 being higher than AP3. So what happens when it's true? When it is true, the wall height becomes AP6's height. So we'll set the variable value. We are not defining a new variable, we're just setting its value. So that is why we selected this one. What variable are we changing? We're changing the wall height. And what is it becoming? It's becoming AP6's height. In the case that that is not true, which is AP6 is not higher than AP3, nothing is going to happen. At the end, we're going to have a height, and that will be So yes, nothing is going to happen and the wall height will stay AP3's height. Now that we have a variable wall height, we also have to tell it not to build anything in certain situations. The first situation is we don't want it to build anything if the wall height is less than 0. The second situation is if AP6 becomes higher than AP4, because what that will mean is that, let me drag this up here. What that will mean is that our grading, the maximum we could go, is too low for the water table. In that situation, something has to be fixed, which might be the profile, but this is just not feasible anymore at this point, and the subassembly should not build. So we'll add another decision, and coming into this, both sides will lead us here, because the only thing that would be different from both of these would be the wall height. But after that, they're trying to do the same thing. The expression that we have to meet the conditions of are wall height being greater than 0 and AP6 being less than AP4. So if these are met, we are ready to go on to the next step, and that is when to build the wall. The next step and the final step, which I also think is the easiest step, is actually building our wall. We are no longer using auxiliary points. These are points that will actually show up in Civil 3D. And so instead of coming down here, we'll go up to where it says points, and we'll add the first point, which is going to be at the bottom of the wall. For that, we need to give it AP1 as its location. And right now, we have it only building if everything before it is true. And right now, this situation that we have over here is not true. So you can see there's no AP1 because we're above the max grade. But if we come just a little bit lower, AP1 will pop up. I can drag it above that point and it'll disappear. So we'll leave it down here because we want to see it build the top of the wall. That will be AP2. For that, we want delta x, delta y from P1. Delta y will be the wall height. Wall height. And there we are. This is building a wall up to AP6 because it is above the minimum for the grade. If that was not an issue, the wall height would stay with the elevation that's the minimum. Now, we saw it that if it was too high, it didn't build. But now, if the wall height becomes less than 0, it also should not build. Then in this situation, it's building and it's staying there until we are below the minimum. And now it's following that. And now it's not building. So that's everything we needed it to do. And we'll just go a quick rundown again of everything that we did. And we'll take a look at everything in Civil 3D. So yes, we'll be taking a look at everything we did and adding comments so that it's a little bit easier to follow and it will give us a quick recap of everything. So AP1 was the wall bottom. So we'll just add that comment, wall bottom. We'll turn on the comments so that we can see everything that we're doing. AP2 was the grade origin. which was the target. This needed a target. This just needed an input. This point was the minimum grade, and that needed an input and the use of some math, which we have right here. For that comment, we'll use min grade. Okay. I guess it's going to give the comment to the link too. For this one, it's the opposite. It's the max grade. And this is the same as the minimum. The only difference was that this was positive. The next thing we did is we set a surface target. And we'll go ahead and comment e.g. AP6 was the maximum depth. And this was based on the surface target and then an input for the delta y. We then defined the wall by default to be the minimum grade. We had a couple of decisions to make. The first decision is the max depth greater than the minimum grade? If it was, then we wanted that to be the new wall height. If it was not, then the default was still there. The next decision was, is that wall height greater than 0, which is the only reason we would even need a wall, but is it less than the maximum grade? Because if it's higher than that, this is too steep, and this design needs to change in other aspects which are not able to be done by the wall. If everything checked out, that's when we started to build our wall. P1 was the wall bottom and P2 was the wall top. We'll go ahead and add we're going to add point codes, and this will show up in Civil 3D as feature lines. For this, we'll say wall top. This has to be in quotes, and we'll say wall bottom. Wall bottom. We'll do a little bit more testing, just making sure everything is working. And so everything looks like it checks out. It only builds when we want it to build. One more thing I will mention is that this is in roadway mode. There is another mode. This is almost simulating the subassembly being used. Layout mode is what is showing up when you first insert it into an assembly, and it knows nothing as far as the targets. So here it looks correct. In the layout mode, it might not look correct because we don't have the targets in there. It's just adding everything based on defaults. So for right now, we know that in the roadway mode, everything is checking out. We should be ready to use our subassembly, and hopefully it's working and it's given us a dynamic and easy to use way of determining these wall heights. Before we switch over to Civil 3D, a couple of things I did off screen was to test it, make sure it was working, and I realized that we forgot one part, and that is showing the grade coming off the top. And the reason for that is that right now, this wall thickness, we did put in 3, but since we're only showing the back of the wall, which is the important part, once I brought it into Civil 3D, it wasn't apparent where the wall was. So we're going to add this grading, and that grading will show us where the wall is. Alternatively, We could also keep adding parts to this wall, including the front face, and any other thing that we might want to add to it. But for right now, just to keep this simple, we're just going to add that grading. So in order to do that, we're going to add another point. It looks like we're running out of space here, but you can always make this window bigger. Oh. Okay, so we're going to add a point, and this point will be based on AP2, which is the grade origin. And we are going to want to link okay, it looks like we're going to have to add the link separately. So for us to do that, we put AP3, which is the grade origin, and we'll now add the link. The starting will be P3, and P2 will be the other end of it. So there it is. Let's do a little bit more of shifting things around, seeing how that's going to look, right? At this point, the depth is not a concern anymore. And I think we're ready. So I went ahead and gave it a name. AC, EC, wall 1. I'm going to change it to 0.1. The reason is that I already brought this into Civil 3D, and it's not going to like it if it has the same name. 0.1 is not an option, so we'll do 2. And that name is actually independent of the file name. I'm going to name that ACC2. Okay, and we're ready now. Okay, so now that we're back in Civil 3D, what I've done is I've created two sections of the corridor. Like I said, this was just strictly for the walls. This was not anything that was going to go into actual data shortcuts or anything like that. So I created just the sections of the roadway that I needed, which is the target roadway over here, and then over here is where the wall will be. And just as a little background here, what we have going on is we have a roadway going north that is at existing grade, westbound is under it, and before westbound keeps going to the left, over here we have a ramp that brings you down, and then they merge over here. So at this point, this part of the ramp is at existing, and then it gets lower, but the roadway next to it is already down below the intersection. And so we need a wall right here. We just don't know how long the wall is supposed to go. And so that's why we created that assembly, or subassembly, sorry. I went ahead and brought it in here from import subassemblies, just right clicking there. And this was the first one I made, the one that was missing the grading, and here is the one we just made. So I'll go ahead and insert it, and we'll take a look at some of the things that we are able to input. So these are once again the inputs that we had. Wall thickness, I'm gonna change to let's do 2, and the depth was 12 feet. I think I'm gonna do 10. I'm hoping that it will create a wall where the wall height would be 0 if it wasn't limited by the depth. So let's do 10, grade 2 to 1, okay. So this assembly is creating this part. We'll go ahead and edit those targets. The surface target is existing, and there's grading X and grading Y. So we'll go ahead and select the feature line for that corridor. Okay, everything else looks good. And we'll create that corridor. So as you can tell, it now adds another section of grading, and the grading goes a little bit further than what we have drawn in right now. We'll take a look at this in 3D to see how it's looking. So as you can see that it's adding a wall there, and that wall is changing dynamically with what the adjacent roadway is doing. And right at that point, it zeroes out and it no longer creates the wall, meaning that the wall height would be 0. And so what I'm going to do as a further test is that depth, I am going to decrease it to, we have 10 right now, I'm going to decrease it to 5, and I'm hoping that this part changes. So we'll go ahead and change that depth to 5. All right. Like I said, I'm hoping this gets longer on this side. And it looks like it did. I want to see a point where that zeroes out to. Okay, so it's not, that's not going to do it. We'll play around with it a bit. Let's try 7. Okay, so you can see that with 7 feet, the profile for both roadways stayed the same. The only reason this got longer was that it's getting longer for the depth, and so that would tell us that this is working correctly, and that we're able to hit that 7 feet depth and then still build the wall up to that point. So we'll take another look at that. Okay, it is the other angle that we wanted. Right there. And yeah, so the profile for this roadway comes up a bit, and so that is where 7 feet is still working and the wall is 0. So that has been my introduction to Subassembly Composer and how you can use it to derive some of the design elements that you might need on a project. In our situation, it was a wall. There's a lot of things you can do with Subassembly Composer, and hopefully now that you know how to set input parameters, targets, how to create points, auxiliary points, also take some of the workflows that I used, which was creating auxiliary points first, then having decisions in order to know when to make actual points is useful. And hopefully you're able to apply this later down the road in some of your projects, because I think that it simplifies a lot of things. For example, in this situation, that 12-foot depth was changing, and also some of the geometry over here, how this splits off was changing, the profiles. This whole project was a lot of changing, and I don't think I could have done it without having something be dynamic, because I would come here, I would synchronize the shortcuts, see that this profile changed. All I had to do is, after synchronizing, just rebuilding the corridor, and this would update. And it was very easy to keep track of that, and then also pass on that wall height by extracting the feature lines from the top of the wall, and just letting the wall design team know, all right, that's like the minimum that you have to hit. And it was just a lot quicker and more simple, and I think a lot more accurate, because you're not just tracing things at this point, it's actually calculating it at that specific station, what the height has to be. And so that's why I used it, and hopefully you find some use in this lesson and with the program itself. Thank you.